In the vast, dark silence that lies between the stars, a lone emissary from Earth continues its timeless journey, NASA's Voyager 1 spacecraft, a symbol of human curiosity and ambition. Launched in 1977, Voyager 1 was part of an extraordinary mission that would go on to define an era in space exploration. Together with its twin, Voyager 2, it was built to explore the outer planets. But what it ultimately achieved surpassed every expectation. The Voyager missions marked a watershed moment in the history of space science. Designed initially to conduct close-up studies of Jupiter and Saturn, these pioneering probes delivered breathtaking images and unprecedented data, transforming our understanding of the gas giants and their moons. Yet, even as Voyager 1 completed its original mission, it kept going, pushed onward by the relentless drive of discovery embedded in its very design. Voyager 1's journey did not end at the edge of the solar system. Instead, it became the first man-made object to enter interstellar space, crossing the Heliosphere, the boundary where the solar wind gives way to the interstellar medium, on August 25, 2012. With this historic achievement, Voyager 1 stepped beyond the protective bubble of our Sun's influence into a new and uncharted realm. It was a leap not just across space, but across the boundaries of human knowledge. As it travels more than 14 billion miles from Earth, Voyager 1 continues to send back signals, whispering secrets from a region of space no other human-made craft has ever visited. It relays vital information about cosmic rays, magnetic fields, and the density of interstellar plasma. Clues that help scientists piece together the nature of the space between stars. But Voyager's legacy is more than just data. It is also deeply philosophical and symbolic. Affixed to the spacecraft is the Golden Record, a phonograph containing sounds and images selected to portray the diversity of life and culture on Earth. It includes greetings in 55 languages, music from across the world, and even the brainwaves of a young woman in love. This record is a message to the cosmos, a hopeful gesture that speaks to our species' longing to connect with whatever might lie beyond. In every sense, Voyager 1 is more than a spacecraft. It is a time capsule, a sentinel, and a storyteller. It has witnessed the auroras of Jupiter, the rings of Saturn, and now the strange silence of the interstellar deep. Its journey reminds us that exploration is not just about where we go, but what we learn about ourselves along the way. Even now, over 4 decades since its launch, Voyager 1 continues its odyssey, a tiny speck in a vast ocean, sailing ever farther into the unknown. It carries with it the dreams, questions, and hopes of a planet bound by gravity, but driven by imagination. As long as Voyager 1 speaks, even in the faintest signals, humanity is still out there, listening, learning, and reaching for the stars. Voyager 1, the unstoppable explorer, and a recent cosmic silence. Voyager 1's epic odyssey through our solar system and beyond is nothing short of legendary. Over the decades, this pioneering spacecraft has peeled back the veils of cosmic mystery, unveiling long-hidden secrets that have deepened our understanding of the universe. From the swirling storms of Jupiter to the icy rings of Saturn, Voyager 1 has offered us front-row seats to the most majestic sights in our solar neighborhood. But its greatest achievement lay ahead. When it crossed into interstellar space, Voyager 1 shattered the final frontier, becoming our first messenger to venture beyond the protective bubble of the Sun's influence. And even now, more than 45 years after its launch, Voyager 1 continues to surprise us. Scientists across the globe are still interpreting the groundbreaking data it transmits, confirming new findings that have the potential to revolutionize astrophysics and reshape how we understand the cosmic environment that surrounds our solar system. Every byte of information sent back from this tiny spacecraft, now over 14 billion miles away, is a treasure trove for science. The legacy of the Voyager missions is monumental. They stand not just as triumphs of engineering and science, but as symbols of humanity's insatiable curiosity and unwavering desire to push boundaries. They are beacons of inspiration, reminding us that even the smallest emissaries can carry the weight of our greatest dreams. However, Voyager 1's journey has not been without challenges. Recently, the mission encountered a puzzling interruption. After decades of steady communication, the spacecraft began sending back distorted data to Earth, signals that confused even seasoned mission engineers. It appeared that Voyager 1's telemetry system, which reports on the status and health of the spacecraft, was malfunctioning. For a time, it was as if our voice in the stars had gone faint, as if a long-trusted friend had grown distant and unrecognizable. But in true Voyager spirit, the story didn't end there. The incredible team at NASA's Jet Propulsion Laboratory sprang into action, navigating decades-old software, ancient hardware, and limited resources to diagnose the issue. In a feat of modern-day engineering wizardry, they managed to recover, contact, and restore normal communication, once again proving that even across unimaginable distances, human ingenuity can bridge the void. So join us in today's video as we dive deep into the story of Voyager 1, its triumphs, its mysteries, and the remarkable resilience of both machine and mankind. From its humble beginnings on Earth to the farthest edge of the solar system, this is more than a mission. It's a journey into the very soul of what it means to be human. The stars still call, and Voyager 1 is still answering. Voyager's original mission, a leap into the unknown. When the Voyager mission was conceived in the early 1970s, it was nothing short of audacious, a daring leap into the unknown. The primary objective was ambitious: to collect detailed data on the 4 giant outer planets of our solar system, Jupiter, Saturn, Uranus, and Neptune, through close-up exploration that had never before been attempted. At that time, these planets remained largely mysterious, distant orbs observed only through Earth-bound telescopes. Their complex systems of moons, magnetic fields, atmospheres, and potential ring structures were shrouded in uncertainty. Voyager was designed to change that forever. The mission sought to pull back the cosmic curtain, sending back high-resolution images and scientific measurements that would unravel the secrets of these colossal worlds. From the swirling storms of Jupiter to the elegant rings of Saturn, from the icy blue expanse of Uranus to the deep azure hues of Neptune, the Voyager spacecraft promised to deliver a view of the outer solar system unlike anything humanity had ever seen. But despite the excitement, skepticism loomed large. Many questioned whether the spacecraft could even survive the launch, let alone withstand the immense distances and harsh conditions of deep space. These concerns were far from unfounded. After all, no mission had ever attempted such an extensive voyage through the outer solar system. The journey would take years. The technology was untested on such a scale, and there were no guarantees of success. Fuel limitations, signal delays, mechanical failures. Any number of problems could have ended the mission prematurely. And yet, the team pressed on. Against the odds, Voyager 1 and its twin, Voyager 2, not only survived, they thrived. They conducted flawless flybys of the target planets, capturing images that astonished the world and collecting data that transformed planetary science. Thanks to Voyager, we discovered active volcanoes on Jupiter's moon Io, observed complex weather systems on Neptune, mapped intricate magnetic fields, and even detected unexpected ring systems around planets like Uranus. What was once theory became fact. What was once invisible became breathtakingly real. In hindsight, what seemed like a gamble turned into one of the greatest scientific triumphs in human history. And remarkably, the mission didn't end with the outer planets. Voyager's story was just beginning. Propelled by its own momentum, Voyager 1 journeyed on, setting its course for the stars. Today, it continues its odyssey in interstellar space, carrying with it a golden record, a message from Earth, a time capsule for any distant intelligence that might one day discover it. Voyager's triumph, a legacy of ingenuity and discovery. However, against all expectations and despite immense technical hurdles, the Voyager spacecraft defied all odds, embarking on an extraordinary odyssey of scientific exploration, an odyssey that continues to shape our understanding of the cosmos even to this day. Launched in 1977, Voyager 1 and Voyager 2 were more than just spacecraft. They were symbols of human ingenuity, resilience, and an insatiable thirst for discovery. At a time when direct data on the outer planets was scarce and only a handful of missions had ventured beyond Mars, Voyager dared to do the impossible. It pushed the boundaries of our planetary knowledge, becoming the first mission to provide close-up images and in-depth data on Jupiter, Saturn, Uranus and Neptune, forever transforming how we understand the gas and ice giants that inhabit the outer reaches of our solar system. Engineers and scientists faced enormous challenges. With no precedent for such a long and complex journey, obtaining precise measurements of distant planets, their atmospheres, rings and moons, was a formidable task. The vacuum of space, intense radiation belts, signal delays across billions of kilometers, these were just a few of the formidable obstacles the mission had to overcome. And yet, Voyager was ready. Both spacecraft were equipped with a suite of 11 advanced scientific instruments, each meticulously designed to capture different aspects of the planets and their environments. These included imaging systems for capturing detailed photographs of planets, moons, and ring systems, infrared and ultraviolet spectrometers to analyze atmospheric composition and thermal radiation, magnetometers to measure magnetic fields, cosmic ray and plasma detectors to study solar wind and interstellar particles, photopolarimeters and radio science instruments to probe planetary densities and structures. With these tools, Voyager did far more than anyone expected. It discovered volcanoes erupting on Io, detected complex ring structures around all 4 outer planets, revealed the dynamic, storm-filled atmospheres of gas giants. The data returned by Voyager laid the groundwork for every outer solar system mission that followed, from Galileo and Cassini to Juno and beyond. More importantly, it ignited the public imagination, demonstrating that we are capable of reaching out across the vast emptiness of space, not just to see, but to understand. Voyager didn't just travel far. It changed everything we thought we knew about the outer solar system. engineering the impossible, how Voyager defied the darkness of deep space. At the heart of the Voyager missions lies a symphony of sophisticated engineering and scientific ambition. Each probe, Voyager 1 and Voyager 2, was equipped with a suite of highly specialized instruments designed to explore the farthest frontiers of our solar system. These included photometers, magnetometers, cameras, charged particle detectors, radio antennas, and plasma detectors, each playing a crucial role in analyzing planetary environments, magnetic fields, radiation belts, and distant atmospheric phenomena. Yet, deploying this technology posed a monumental challenge. Operating sensitive instruments billions of kilometers away from the Sun in the cold, silent void of deep space was an unprecedented task. Unlike missions closer to Earth, Voyager could not rely on solar panels for energy, as the Sun's light was too faint to be of any practical use. To overcome this hurdle, NASA engineers turned to nuclear energy, harnessing the power of radioisotope thermoelectric generators, RTGs. A brilliant solution that would become the backbone of Voyager's longevity. Each spacecraft carried plutonium-238, a radioactive material whose natural decay produces heat. The RTGs ingeniously converted this heat into electricity, ensuring a steady, reliable power source that would function regardless of the spacecraft's distance from the Sun or the passing of decades. These compact power plants enabled Voyager's systems to remain operational even as they traverse the frozen frontiers of space, where temperatures plummet to hundreds of degrees below zero and sunlight is a distant memory. Each Voyager spacecraft carried approximately 722 kilograms of payload, comprising scientific instruments, communication systems, and power sources, all meticulously arranged to withstand the harsh rigors of space travel. The probes had to operate with extreme autonomy, capable of managing critical functions and making real-time decisions based on pre-programmed algorithms due to the immense communication delay with Earth. Thanks to this visionary engineering, the Voyager twins have transmitted invaluable data for over 4 decades. They have rewritten textbooks, uncovered new planetary phenomena, and extended the reach of human understanding into the interstellar medium, a realm no spacecraft had ever entered before. The story of Voyager is not only a triumph of science, but also a resounding testament to human creativity, problem-solving, and our determination to seek knowledge, no matter how distant the destination may be. Strategic precision. How NASA engineered the grand tour of the outer planets. Sending a spacecraft into the vast and unforgiving expanse of our solar system is no small feat, especially in the 1970s, when spaceflight technology was still in its relative infancy. The Voyager missions required not only remarkable engineering and endurance, but also strategic genius to ensure their success. One of the key challenges was power management. For the spacecraft to function efficiently and avoid aimless drifting through space, they required substantial and uninterrupted power. A task that NASA solved with the use of radioisotope thermoelectric generators. But generating power was only part of the equation. Planning the journey itself demanded equal brilliance. NASA's engineers meticulously charted the mission trajectories, utilizing an ingenious technique known as gravity assist, a maneuver in which a spacecraft uses the gravity of a planet to gain speed and alter its course. By harnessing the gravitational pull of Jupiter and Saturn, the Voyagers could be slingshotted farther into the solar system without expending extra fuel, allowing them to travel vast distances with remarkable efficiency. The timing of the mission was critical. In the late 1970s, the outer planets Jupiter, Saturn, Uranus, and Neptune were entering a rare, favorable alignment that occurs only once every 176 years. This unique positioning allowed for what NASA called the Grand Tour, a chance to visit all 4 giant planets in a single mission, using consecutive gravity assists to propel the spacecraft from one planet to the next. Initially, NASA envisioned a single ambitious spacecraft to complete this entire tour. However, due to budgetary constraints and technical risks, the agency opted for a more cost-effective and flexible solution, launching 2 identical spacecraft, each with its own specific trajectory and mission goals. Thus, Voyager 1 and Voyager 2 were born. Voyager 1 was designated to fly by Jupiter and Saturn, getting close enough to study their atmospheres, moons, and rings in unprecedented detail. Voyager 2, meanwhile, was tasked with exploring all 4 outer planets: Jupiter, Saturn, Uranus, and Neptune, becoming the only spacecraft in history to have visited all of them. Despite the limitations of 1970s technology, no GPS, no onboard AI, and minimal computer memory, NASA's planning left no stone unturned. Every trajectory calculation, communication schedule, and instrument command had to be programmed in advance with precision and foresight. There was no room for error in the dark and distant void. Against all odds, the Voyager mission persevered. What started as a bold idea evolved into one of the most iconic and enduring achievements in the history of space exploration. These spacecraft not only survived the journey, but also exceeded every expectation, becoming the longest operating and farthest traveling spacecraft humanity has ever launched. Voyager 1's encounter with Jupiter, a turning point in planetary science. When NASA launched the Voyager spacecraft, it did so with high hopes and bold ambitions, but much of what the mission might reveal remained rooted in optimistic speculation. At the time, the outer planets were enigmatic giants, their moons little more than distant, blurry dots captured in telescopic glimpses from Earth. Yet the Voyager mission pressed forward, determined to overcome the uncertainties and break through the boundaries of human understanding. In 1979, Voyager 1 reached Jupiter, the largest planet in our solar system. What unfolded during this flyby marked a historic turning point in planetary science. Among the many stunning revelations, one in particular captured the imagination of scientists around the globe. Jupiter's moon, Io, long thought to be just another rocky satellite, was found to be geologically active. This was a revolutionary discovery. Up to that point, Earth had been considered the only body in the solar system with active geology, volcanoes, tectonic movements, and internal heat flow. Io, smaller than Earth's moon and just a third the size of Earth, defied all expectations. Voyager 1 captured astonishing images of Io's surface, erupting volcanoes, shifting terrain, and widespread lava flows, revealing that this tiny moon was the most geologically active object in the entire system. Even more remarkable was the intensity of Io's activity. Despite its modest size, Io was generating twice as much internal heat as Earth. This immense energy output wasn't due to radioactive decay or solar heating, but rather the result of tidal heating, a process driven by the gravitational tug-of-war between Jupiter and its neighboring moons, Europa and Ganymede. As Io orbited the gas giant, it experienced constant flexing, causing its interior to heat up dramatically and fuel continuous volcanic eruptions. The surface of Io, unlike anything seen before, was a vibrant mosaic of sulphurous plains, towering plumes, and lava lakes, with colors ranging from yellow and orange to red and black. Some volcanic plumes were found to erupt hundreds of kilometers into space, a spectacle that redefined scientists' understanding of how dynamic a moon's surface could be. This discovery alone would have been enough to cement the success of the Voyager program, but it was only the beginning. Voyager 1's findings at Jupiter, and particularly at Io, reshaped planetary science. It proved that geologic activity was not limited to Earth, opening the door to new theories about potential habitability on other moons, such as Europa, and later Enceladus and Titan. Voyager 1's flyby of Jupiter was more than a mission milestone. It was a moment that changed the way we look at the solar system. It reminded us that even the most unassuming celestial bodies could hold astonishing surprises, and it underscored the value of exploration, venturing into the unknown, driven by curiosity, only to discover realities far more wondrous than imagined. Voyager 1's discoveries at Jupiter, redefining planetary science. The Voyager 1 mission's close encounter with Jupiter didn't just provide breathtaking visuals of the largest planet in our solar system. It shattered long-held assumptions and revolutionized our understanding of gas giants and their complex systems. Among its most surprising revelations was the geologic dynamism of Io. But that was just the beginning. As Voyager 1 continued its flyby, it unveiled a tapestry of scientific findings that would forever change how we study the cosmos. One of the most unexpected discoveries was the enormity and strength of Jupiter's magnetosphere, the magnetic field that surrounds the planet. Previously, scientists had underestimated its scale, but Voyager 1 revealed that Jupiter's magnetosphere is the largest structure in the solar system, stretching outward until it nearly reached the orbit of Saturn, a distance of over 10 million kilometers. This discovery emphasized just how powerful Jupiter's magnetic influence is, affecting not only its own moons and rings, but also the solar wind far beyond what anyone had predicted. The probe's suite of instruments also penetrated the secrets of Jupiter's atmosphere. It analyzed the planet's composition in unprecedented detail, detecting a mix of hydrogen and helium, the primary elements as expected, but also traces of water vapor, methane, ammonia, and even rocky materials. These findings provided scientists with valuable clues about Jupiter's internal structure, formation history, and the dynamic processes taking place in its turbulent clouds. Through high-resolution imaging and data collection, Voyager 1 captured images of Jupiter's Great Red Spot, a massive storm that had already raged for centuries, and unveiled swirling cloud bands, chaotic atmospheric motions, and fast-moving jet streams. The planet's ever-changing weather systems, driven by internal heat and rapid rotation, painted a vivid picture of a world alive with activity, despite having no solid surface. Even more astonishing was what Voyager uncovered about Jupiter's moons. Not only Io, but Europa, Ganymede, and Callisto. Each of these Galilean satellites showed unique characteristics, from cracked icy surfaces to evidence of internal oceans, hinting at the possibility of subsurface water and even conditions suitable for life in the most unexpected places. These findings collectively expanded the scientific paradigm. Before Voyager 1, moons were often thought of as cold, inactive bodies, mere rocks orbiting planets. But now, They were seen as diverse and complex worlds, some with active volcanoes, hidden oceans, or mysterious terrain, each deserving of further exploration. Voyager 1's mission to Jupiter served as a powerful reminder. The solar system is far more intricate and alive than previously imagined. What started as a mission to collect data transformed into a voyage of revelation, deepening our understanding of planetary geology, atmospheric dynamics, and magnetic fields on a grand scale. This historic flyby didn't just enrich our scientific libraries, it sparked new questions and laid the foundation for future missions. It also inspired a generation of astronomers, engineers, and explorers to continue humanity's relentless pursuit of knowledge beyond Earth. Voyager's unprecedented discoveries. From Jupiter to Saturn. As Voyager 1 departed the realm of Jupiter, it left behind a treasure trove of discoveries that redefined planetary science. Yet, its journey was far from over. With unwavering precision, the spacecraft set its course for Saturn, the sixth planet from the Sun, and another celestial giant cloaked in mystery. But before we plunge into the wonders of Saturn, it's important to reflect on one final, critical chapter from Voyager's exploration of Jupiter: the unexpected discoveries surrounding its rings and moons. In a stunning revelation, Voyager 1 captured the first up-close image of a narrow, dark ring encircling Jupiter. A phenomenon that had eluded astronomers for decades. The ring's existence, previously undetected from Earth, was believed to be composed of fine dust particles, and possibly the remnants of an ancient moon pulverized by past collisions. This finding challenged assumptions that only Saturn possessed rings and opened a new frontier of inquiry into the dynamics of planetary ring systems. Additionally, Ganymede, Jupiter's largest moon and the largest in the entire solar system, came under intense scrutiny. Voyager 1's sophisticated instruments detected the presence of a tenuous atmosphere, an exosphere composed mostly of oxygen. This was a groundbreaking discovery. Up until then, Ganymede was considered geologically dead and atmosphereless. The existence of this thin atmosphere suggested internal activity and set the stage for later missions, such as the upcoming ESA's Jupiter Icy Moons Explorer, USH, and NASA's Europa Clipper. Together, these findings reshaped our understanding of Jupiter as not just a giant gaseous planet, but a complex system teeming with dynamic moons, active geology, hidden atmospheres, and mysterious rings. It was a microcosm of cosmic diversity, waiting to be studied for generations. Voyager 1, at Saturn, unveiling the secrets of the ringed giant. With its instruments still functioning optimally, Voyager 1 journeyed farther into the outer solar system, setting its sights on Saturn. Arriving in 1980, it encountered a world unlike any seen before, an ethereal planet adorned with breathtaking rings and home to one of the most intriguing moons in the solar system, Titan. Perhaps the most astonishing revelation of this leg of the mission was related to Titan, Saturn's largest moon. As Voyager 1 flew past it, scientists were astounded to discover that Titan's solid core had a smaller diameter than Ganymede, despite Titan being shrouded in a thick atmosphere that made it appear larger from afar. This challenged previously held beliefs and prompted a re-evaluation of how moons formed and evolved. The probe also revealed that Titan's dense atmosphere was primarily composed of nitrogen with traces of methane and complex hydrocarbons. an atmospheric makeup strikingly similar to that of early Earth. Although Voyager 1 was unable to see Titan's surface due to the thick orange haze, it provided strong evidence that liquid lakes or seas could exist beneath the clouds, paving the way for future missions like Cassini, Huygens, which later confirmed the existence of methane lakes. Moreover, Voyager 1's approach offered unprecedented views of Saturn's rings. What once seemed like uniform bands through telescopes were now revealed to be composed of thousands of smaller ringlets, each a delicate structure of ice and rock particles, ranging from microscopic grains to large boulders. The rings displayed intricate wave patterns caused by the gravitational influence of Saturn's moons, adding yet another layer of complexity to the planet's environment. The spacecraft also identified several previously unknown moons orbiting Saturn and revealed intricate magnetic and radiation belts that hinted at dynamic processes happening deep within the gas giant's core. A legacy of discovery. The discoveries made by Voyager 1 at Jupiter and Saturn were more than just data points. They were revelations that forever altered our perception of the solar system. Each encounter unveiled phenomena that defied expectations, challenged theories, and inspired countless new questions. By capturing stunning visuals, analyzing complex atmospheric compositions, uncovering geologic activity, and mapping planetary magnetospheres, Voyager 1 expanded the frontier of human knowledge. Its journey stands not only as a testament to human ingenuity and curiosity, but as a gateway to understanding our place in the vast cosmos. And yet, the Voyager story doesn't end at Saturn. As the probe moved beyond the gravitational grip of our major planets, it ventured into a new and uncharted domain, interstellar space. Becoming the first human-made object to do so, the Voyager missions unveiled the magnificent moons of Saturn in unprecedented ways, providing invaluable data that continues to fuel scientific research decades later. These missions stand as a towering testament to human ingenuity and the unquenchable thirst for exploration and discovery. Voyager's meticulous exploration of Saturn marked a significant milestone, unearthing astonishing findings about our nearest gas giant neighbor. Despite Saturn being one of the most studied planets in our solar system, the mission revealed that even worlds we think we understand can still harbor unexpected surprises. These discoveries remind us that close, detailed examination often uncovers hidden complexities that reshape our understanding. While the Voyager probes gathered a wealth of information during their initial flybys, their journey did not end there. As they continued on their path toward interstellar space, the probes presented scientists with a unique opportunity to delve even deeper into the nature of these planets and their surroundings. Through detailed investigations, the Voyager spacecraft revealed new phenomena, expanding our knowledge far beyond what was previously imagined and setting the stage for future exploration of the outer solar system. With meticulous data collection and thorough analysis, the Voyager missions provided scientists with a deeper understanding of Saturn's atmosphere, magnetosphere, rings, and moons. The probes uncovered new and intricate features, such as complex ring structures, dynamic storm systems, and previously unknown atmospheric phenomena. These findings dramatically expanded our comprehension of this gas giant, revealing its secrets in ways that had once seemed unimaginable. The wealth of data gathered from Voyager's in-depth studies not only enriched our knowledge of Saturn, but also deepened our broader understanding of the outer solar system. These missions continually fuel human curiosity and the drive for exploration, standing as a powerful testament to human ingenuity and our relentless pursuit of cosmic knowledge. Voyager probes are forever remembered as pioneering endeavors that broadened humanity's horizons and unlocked new mysteries within the universe. In a groundbreaking announcement in February 2023, astronomers revealed an astonishing new discovery. They had identified 12 new moons orbiting Jupiter, bringing the total confirmed number of moons around the gas giant to an unprecedented 92. This remarkable finding highlights that even decades after the Voyager missions, the outer planets continue to surprise and captivate us, offering endless opportunities for discovery. This extraordinary discovery firmly establishes Jupiter as the planet with the highest number of natural satellites in our solar system, surpassing the previous record held by Saturn, which has 83 moons. The dozen newly identified moons were detected and carefully observed using advanced telescopes located in Chile and Hawaii during 2021 and 2022. Following meticulous data collection and rigorous analysis, the discovery was officially confirmed in 2023. This remarkable finding adds significant depth to our ever-growing understanding of the complex and dynamic Jovian system, offering new insights into the intricate gravitational ballet performed by the numerous moons orbiting this massive gas giant. It also highlights the continuous advancements in astronomical observations and reflects humanity's unrelenting curiosity to explore and unravel the mysteries of the cosmos. After their initial detection, the orbits of these new satellites were meticulously tracked and confirmed through extensive follow-up observations conducted by a dedicated team of scientists. This further in-depth analysis has not only validated their existence, but also helped refine our knowledge of their orbital characteristics, stability, and interactions within Jupiter's vast gravitational influence. The discovery of these moons serves as a reminder that despite centuries of astronomical study, our solar system continues to hold surprises, and each new revelation brings us closer to understanding the full complexity of the cosmic neighborhood we call home. Further investigations into these newly discovered moons revealed intriguing details about their characteristics. Ranging in size from 1 to 3 kilometers, these moons were identified as regular satellites exhibiting retrograde motion, meaning they orbit Jupiter in a backward direction, opposite to the planet's rotation. This unusual orbital behavior highlights the complex gravitational interactions shaping the Jovian system. Moreover, astronomers determined that the moons display a diverse range of orbital periods. Some take several years to complete a single orbit, while others complete their journeys in just a few months before repeating the cycle. This variation showcases the dynamic and intricate motions of these celestial bodies within Jupiter's vast gravitational sphere. These recent discoveries offer compelling new evidence supporting the pioneering observations made during the Voyager mission of 1979. That historic mission had hinted at the existence of a significant population of moons around Jupiter, and now, with the addition of these newly confirmed satellites, astronomers possess even more robust data to confirm Jupiter's remarkable abundance of natural moons. Such findings underscore the continuous progress in our understanding of the Jovian system and provide valuable insight into the complex dynamics governing the interactions among Jupiter's moons. They fuel our scientific curiosity and deepen our appreciation for the wonders of the universe, reminding us that despite decades of exploration, the cosmos still holds countless mysteries waiting to be uncovered. In the coming months and years, several ambitious space missions by leading space agencies are poised to deepen humanity's understanding of Jupiter and its intriguing moons, ushering in a new era of planetary exploration. Among these, the European Space Agency, ESA, has set its sights on launching a sophisticated spacecraft in April 2023. This mission is designed to study Jupiter and its diverse icy moons with enhanced precision and advanced instrumentation, aiming to unravel the mysteries that surround these distant celestial bodies. The spacecraft will focus on gathering comprehensive data about the planet's atmosphere, magnetosphere, and the unique geophysical features of its moons. Simultaneously, NASA is preparing to launch its highly anticipated Europa Clipper mission, slated for the near future. This mission targets Europa, one of Jupiter's most enigmatic moons, long suspected to conceal a vast, potentially life-supporting ocean beneath its thick icy crust. The Europa Clipper aimed to perform detailed reconnaissance of the moon's surface and subsurface, analyzing its ice shell, ocean depth and composition, as well as identifying possible locations where life could exist. By probing the ice shell's fractures and geysers, the mission seeks to better understand Europa's habitability and assess its potential to support microbial or even more complex life forms. These forthcoming missions promise to deliver an unprecedented wealth of data and insights, fundamentally enriching our comprehension of the Jovian system and advancing the broader quest to understand the conditions necessary for life beyond Earth. The discoveries made by these spacecraft will not only expand our knowledge of Jupiter and its moons, but will also shed light on planetary formation, geological processes, and the dynamics of icy worlds throughout the solar system. Breakthroughs in studying gas giants like Jupiter and Saturn have, in recent decades, opened up entirely new mysteries and avenues for exploration. These planets are not just distant giant worlds. They are dynamic environments with complex weather systems, powerful magnetic fields, and a rich collection of moons, many of which may be ocean worlds. Understanding these systems can provide key insights into the early history of the solar system and the potential for life in environments vastly different from Earth. Looking to the future, advances in space travel technology such as theoretical developments in light speed or near-light speed propulsion may one day allow astronauts to visit the surfaces of these gas giants or their moons directly. While such technology remains speculative and faces significant engineering and physical challenges, it embodies humanity's relentless drive to push boundaries and expand the frontiers of exploration. Visiting Jupiter's and Saturn's moons in person would revolutionize planetary science by enabling direct sampling, detailed surface studies, and on-the-spot investigations of their atmospheres and geophysical characteristics. As we continue this unfolding journey to uncover the secrets of our solar system and beyond, the role of these upcoming missions cannot be overstated. They represent humanity's insatiable curiosity and unwavering commitment to exploring the cosmos, reminding us that despite centuries of study, the universe remains a vast frontier filled with boundless wonders and unanswered questions. We encourage all space enthusiasts and curious minds to stay tuned for updates from these groundbreaking missions, follow the latest discoveries, and share their thoughts and excitement about the future of space exploration. Together, we partake in an unending voyage towards unlocking the secrets of the cosmos, a journey that promises to transform our understanding of the universe and our place within it. The wonders of space exploration truly are boundless, and each new mission brings us closer to grasping the full majesty and mystery of the heavens above. Scientists have recently uncovered extraordinary evidence about a fascinating location within our solar system, one that holds the potential to support life beyond Earth, the icy moon known as Enceladus, which orbits Saturn. Once thought to be a barren, frozen world, Enceladus has now emerged as a prime candidate in the search for extraterrestrial life due to its unique and complex chemical makeup. Data gathered from past missions, especially NASA's Cassini spacecraft, revealed that beneath its thick icy shell lies a hidden ocean of liquid water, enriched with organic molecules essential for life. This subsurface ocean periodically vents plumes of water vapor and ice particles through cracks near the moon's south pole, shooting material high into space. These remarkable geysers suggest that Enceladus has a dynamic interior with the chemical ingredients and environmental conditions that might allow microscopic life to thrive. Scientists are now eagerly preparing for future exploratory missions aimed at sampling these plumes directly to better understand the moon's habitability and the possibility of life in such an extreme environment. Meanwhile, in a very different sphere, a wave of intrigue and excitement has swept through both government circles and the public due to recent disclosures by the US Army. Authorities have declassified a collection of NASA footage that reportedly shows a massive and mysterious unidentified flying object, UFO, sparking intense speculation and discussion worldwide. This footage, which depicts an enormous craft exhibiting flight characteristics beyond current human technology and defying conventional explanation, has challenged established perceptions about aerial phenomena. The revelation has reignited debates over extraterrestrial visitation and the extent of governmental knowledge and transparency regarding such encounters. While scientists and officials urge careful analysis and cautious interpretation, the footage undeniably fuels public curiosity and fascination about what might be lurking in our skies and beyond. Together, these two stories, one grounded in rigorous scientific discovery, the other steeped in mystery and speculation, highlight humanity's relentless curiosity about the universe. The discoveries about Enceladus open up promising new avenues in our quest to find life beyond Earth through methodical, evidence-based exploration. In contrast, the revelation of the UFO footage taps into the imagination and wonder about the unknown, reminding us of the vast mysteries that still elude scientific explanation. Both narratives inspire us to continue exploring and questioning our place in the cosmos, driving humanity's enduring fascination with the stars and the secrets they hold. Stretching over an astonishing 2,000 miles in length, this enigmatic object appeared near the planet Saturn and was captured by some of NASA's most advanced telescopes and satellites. The sheer size and mysterious nature of this colossal UFO have sparked widespread fascination and intense debate among scientists, space enthusiasts, and conspiracy theorists alike. But what exactly lies behind this massive and baffling object? Is it the result of a secret government experiment? A highly classified spacecraft built with cutting-edge technology unknown to the public? Or could it be an actual extraterrestrial spacecraft originating from a civilization far beyond our solar system, silently observing or even visiting our cosmic neighborhood? In this video, we dive deep into the astonishing details recently unveiled by the US Army concerning NASA's footage of this extraordinary 2,000-mile-long UFO near Saturn. The revelations have sent shockwaves through the scientific community and the general public, raising profound questions about the nature of life beyond Earth and the mysteries hidden in the vast reaches of space. Adding to the intrigue is the testimony of former U.S. Army Command Sergeant Major Robert Dean, who has made jaw-dropping claims about alien encounters based on his extensive military experience. Dean has shared compelling accounts from his time in service, suggesting that the government possesses far more knowledge about extraterrestrial visitation than has ever been made public. His insights lend an additional layer of credibility and mystery to the discussion surrounding this colossal object near Saturn. As we explore this remarkable phenomenon, we weigh the evidence, analyze the footage, and consider the wide-ranging implications. Is this the long-awaited proof of alien life? Or are we witnessing something else entirely? A breakthrough in human technology or an optical anomaly? Whatever the answer, the discovery marks a new chapter in humanity's ongoing quest to understand the cosmos and our place within it. Former U.S. Army Command Sergeant Major Robert Dean has emerged as a compelling voice in the ongoing conversation about extraterrestrial encounters, offering rare and captivating insights into humanity's interactions with alien life. Drawing upon his extensive military background, particularly his critical role at NATO headquarters from 1963 to 1967, Dean's statements carry a weight of credibility that few can match in the realm of UFO disclosure. During his tenure, Dean was deeply involved in sensitive projects and briefings that touched on the implications of extraterrestrial presence on Earth. In 1964, he presented a classified assessment paper to NATO officials that analyzed the possible consequences and strategic responses to alien activity. This report, highly confidential at the time, underscored the seriousness with which military leadership regarded the phenomenon, moving it beyond the realm of mere speculation or folklore. At a landmark event commemorating the 50th anniversary of the Roswell incident, one of the most iconic and controversial moments in UFO history, Dean delivered a revealing presentation at Leeds University that stunned attendees and reignited debate worldwide. He disclosed that, during his active service, he had direct knowledge of 4 distinct extraterrestrial groups operating in secret around Earth. However, what is perhaps even more startling is that by the time he retired, this number had expanded dramatically, growing to over 12 separate alien factions. This knowledge was not isolated to just the United States military. Dean suggested that this awareness permeated allied forces, including the British military, indicating a coordinated and perhaps collaborative understanding of these extraterrestrial presences among international defense communities. Such cooperation hints at the possibility that the reality of alien visitation is much more integrated into global security frameworks than previously imagined. Beyond the dozen or so groups Dean directly referenced, he hinted at a far more complex and bewildering cosmic ecosystem. According to his revelations, there may be over 100 different alien organizations with origins that remain shrouded in mystery. These groups vary widely in their intentions, technologies, and methods of interaction with humanity. Some may be peaceful observers, while others might possess agendas that challenge our concepts of diplomacy and security. If Dean's claims withstand rigorous scrutiny, they have the potential to profoundly reshape humanity's understanding of its place in the universe. The existence of multiple alien organizations, each with distinct histories and purposes, suggests a vast and intricate galactic community that intersects with our world in ways we are only beginning to comprehend. This could revolutionize scientific inquiry, international policy, and even the philosophical and spiritual frameworks through which we view ourselves. In a world where official silence and denial have often been the norm, testimonies like those of Major Robert Dean provide a rare glimpse into the hidden layers of reality that many governments and institutions have long kept under wraps. His disclosures invite us to question what we think we know and to remain open to the possibility that the cosmos is far more populated and far more interactive than ever imagined. Major Dean's revelations significantly deepen our understanding of extraterrestrial involvement on Earth, painting a picture of a far more intricate and nuanced relationship between our planet and distant civilizations than previously acknowledged. According to Dean, some of these extraterrestrial beings bear a striking resemblance to humans. These beings are reported to frequent everyday locations, such as aircraft, restaurants, theaters, and other public venues, blending in so effectively that they often go unnoticed by the general population. This ability to integrate undetected has raised profound concerns about the potential infiltration of these extraterrestrials into key institutions of power. Major Dean specifically mentioned places like the SHAPE, Supreme Headquarters, Allied Powers Europe Headquarters, and the Pentagon as locations where these beings might have established a presence. The implications of such infiltration are staggering, as it suggests that these alien entities could influence military strategies, national security decisions, and perhaps even global politics. The prospect of extraterrestrials entering spaces as sensitive as the White House elicited a range of reactions from military officers. Some responded with amusement, treating the idea as something out of science fiction, while others viewed it with genuine apprehension, recognizing the potentially profound consequences of such infiltration on national sovereignty and security. What sets Major Dean's insights apart is his suggestion that humans and these extraterrestrials may share more than just superficial physical similarities. He proposed a unique perspective that humans might share certain commonalities or even genetic links with some of these alien groups, a notion that challenges traditional views of human origins. This concept opens up fascinating possibilities about ancient interactions between humans and extraterrestrial civilizations, potentially explaining myths, legends, and unexplained advancements in human history. Dean's disclosures urge us to rethink our assumptions about identity, security, and the very nature of human civilization. If extraterrestrials have been quietly coexisting among us, influencing events, and perhaps guiding humanity's development in subtle ways, the implications for science, history, and philosophy are profound. This scenario compels us to expand our search for truth beyond the confines of conventional knowledge, and to embrace a broader, more inclusive vision of the universe. As we continue to explore these revelations, the need for transparent investigation and open dialogue becomes ever more critical. Understanding the true extent of extraterrestrial presence and influence could redefine the future of humanity, shaping policies, technologies, and cultural paradigms in unprecedented ways. Major Dean suggested that humans share striking similarities with certain intelligent alien species, hinting at a deeper, undisclosed reason behind this extraordinary connection. He believed that encounters with extraterrestrials transcend mere planetary interactions, involving evolving beings from diverse star systems and even cosmic realms beyond our conventional understanding. According to Dean, this non-human intelligence possesses multi-dimensional attributes with the remarkable ability to manipulate both time and matter, capabilities that challenge and expand our traditional views of the universe's fundamental nature. Switching gears to the monumental achievements of human space exploration, NASA's Voyager spacecraft serve as a testament to our scientific ingenuity and determination to uncover the mysteries of the cosmos. To power these incredible probes on their long and arduous journeys across billions of kilometers, NASA employed nuclear energy through radioisotope thermoelectric generators, RT. These RTGs function by converting the heat produced from the natural decay of plutonium-238 into continuous electrical power, ensuring that the Voyager spacecraft remain operational and transmit vital data back to Earth regardless of their immense distance from the Sun. Each Voyager probe was outfitted with approximately 722 kilograms of scientific instruments, radio systems, and power sources, complex equipment requiring substantial and reliable energy to function effectively. Beyond powering these instruments, the spacecraft needed precise control to maintain their trajectory and prevent aimless drifting through the void of space, highlighting the impressive engineering achievements behind the Voyager missions. Together, the profound mysteries of alien intelligence and the technological marvels of human space exploration illustrate the boundless frontiers that continue to push our understanding of existence, urging us onward in the quest for knowledge that transcends the stars. NASA meticulously planned the Voyager missions, carefully calculating their trajectories by leveraging the powerful gravitational assists provided by Jupiter and Saturn. These gravity assists acted like cosmic slingshots, boosting the spacecraft's speed and enabling them to approach the outer planets with remarkable precision. Every detail was thoughtfully considered, leaving no stone unturned in preparation for this unprecedented journey into the far reaches of our solar system. Exploring the outer planets during the 1970s posed significant challenges. Spaceflight technology was still in its infancy, and navigation systems lacked the sophistication we have today. Despite these obstacles, the Voyager mission pressed forward with unwavering determination. Initially, NASA had envisioned sending a single probe on what was called the Grand Tour, a unique opportunity to take advantage of a rare alignment of the 4 outer planets: Jupiter, Saturn, Uranus, and Neptune. However, budgetary constraints forced a reconsideration of this plan. To maximize scientific returns while controlling costs, NASA decided to launch 2 identical spacecraft, Voyager 1 and Voyager 2, each on separate trajectories designed to explore different parts of the outer solar system. Voyager 1's mission focused on close encounters with Jupiter and Saturn, while Voyager 2 was tasked with venturing farther to study Uranus and Neptune. Voyager 1's arrival at Jupiter marked a breakthrough moment in planetary exploration. Among its most remarkable discoveries was the moon Io, which was revealed to be geologically active, a phenomenon previously believed to be exclusive to Earth. Despite being only about 1/3 the size of Earth, Io displayed volcanic activity that was astonishingly intense, generating twice as much energy as Earth and making it the most geologically dynamic body in our entire solar system. This revelation revolutionized our understanding of the diversity and complexity of celestial bodies, challenging long-held assumptions about planetary geology. Io's surface was dramatically shaped by intense tectonic activity and frequent volcanic eruptions. These dynamic geological processes were driven primarily by powerful gravitational interactions with Jupiter and the other Galilean moons. The immense tidal forces generated by Jupiter's gravity constantly flexed Io's interior, generating heat and fueling its extraordinary volcanic activity. This unexpected discovery fundamentally changed scientists' understanding of the diversity and complexity of celestial bodies within our solar system. It challenged prior assumptions that geological activity was limited to Earth, and expanded our knowledge of planetary geology in profound ways. Voyager 1's mission to Jupiter did not stop with Io. The spacecraft unveiled a wealth of remarkable and unexpected findings about the gas giant itself. One of the most striking revelations was that Jupiter's magnetosphere, the magnetic field surrounding the planet, was far larger and more powerful than previously estimated. It extended billions of kilometers into space, reaching as far as Saturn's orbit, effectively dominating a vast region of the solar system. In addition to magnetospheric discoveries, Voyager 1's instruments detected a complex mixture of elements in Jupiter's atmosphere. These included hydrogen and helium, the primary components, along with trace amounts of water vapor, methane, ammonia, and various rocky materials. This diverse atmospheric composition provided valuable insights into the formation and evolution of the largest planet in our solar system. Voyager 1 also captured the first close-up images of a narrow, dark ring encircling Jupiter. Scientists believe this ring likely originated from debris created by an ancient moon that had broken apart. This discovery added a new dimension to our understanding of Jupiter's ring system, which is far more subtle and elusive compared to the spectacular rings of. Further observations during the mission revealed surprising features about Ganymede, Jupiter's largest moon and the largest moon in the entire solar system. Voyager 1 detected that Ganymede possesses a thin atmosphere, a fact previously unknown before the mission. This tenuous atmosphere, composed mainly of oxygen, provided new clues about the moon's surface and potential geological or exospheric processes at play. These unexpected discoveries profoundly deepened our understanding of Jupiter's magnetosphere, its complex atmospheric composition, and the unique characteristics of its moons. Together, these findings significantly expanded our knowledge of this colossal gas giant and the intricate environment that surrounds it. Following its groundbreaking observations at Jupiter, the Voyager missions pressed onward into the outer solar system, with Voyager 1 leading the charge toward Saturn. The spacecraft's encounter with Saturn proved to be equally remarkable, unveiling astonishing insights into the planet and its moons. As Voyager 1 approached Titan, Saturn's largest moon, scientists were taken aback by a surprising revelation. Titan's solid core was found to have a smaller diameter than Ganymede, the largest moon of Jupiter and indeed the largest in the entire solar system. This discovery was unexpected and challenged earlier assumptions about the sizes and internal compositions of these celestial bodies. This revelation offered a fresh perspective on the remarkable diversity and complexity of moons in our solar system. It provided invaluable data that continues to inform and guide scientific inquiry into the origins, evolution, and dynamic processes of planetary satellites. The Voyager missions significantly expanded our knowledge and understanding of Saturn and its magnificent moons in ways never before achieved. Through their close flybys and sophisticated onboard instruments, Voyager 1 and Voyager 2 provided invaluable data that has fueled scientific research and discoveries for decades. These missions revealed intricate details about Saturn's stunning ring system, its atmospheric dynamics, and the diverse geological features of its many moons, each unique in its own right. From the towering ice cliffs on Enceladus to the dense atmosphere of Titan, Voyager's observations opened new windows into the complexities of the outer solar system. Despite the immense challenges posed by the harsh conditions of deep space, extreme cold, intense radiation, and the vast distances separating Earth from the outer planets, these pioneering spacecraft have continued to operate far beyond their original mission timelines. Their resilience and continued functionality stand as a testament to the ingenuity and foresight of the engineers and scientists who designed them. Even after more than 4 decades, the enduring connection between Voyager 1 and Voyager 2 and NASA's Deep Space Network remains a remarkable technological achievement. This global system of large radio antennas allows the spacecraft to transmit valuable scientific data back to Earth and receive commands from mission control despite being billions of miles away. While Voyager 1 and Voyager 2 may have long since passed the immediate vicinity of the outer planets, their missions are far from complete. Both spacecraft have now entered interstellar space, the vast region beyond the influence of our Sun's solar wind. In this largely unexplored frontier, the Voyagers continue to provide unique insights into the conditions of the interstellar medium, including measurements of cosmic rays, magnetic fields, and interstellar particles, offering humanity an unprecedented glimpse of the environment that exists between the stars. These continued discoveries not only enrich our understanding of the universe around us, but also inspire future generations to push the boundaries of exploration further than ever before. The Voyager missions remain among the most enduring and successful endeavors in the history of space exploration, reminding us that even the most ambitious human ventures can yield rewards for decades and far beyond their original scope. The Voyager missions have fundamentally rewritten the textbooks of planetary science, revolutionizing our understanding of the outer planets and their complex systems. Their groundbreaking discoveries have not only provided invaluable insights into worlds previously unseen, but have also ignited the imaginations of countless scientists, researchers, and space enthusiasts around the globe. These missions stand as shining examples of human curiosity and ingenuity, embodying the relentless pursuit of knowledge about our place in the vast cosmos. As we reflect on the extraordinary achievements of Voyager 1 and Voyager 2, we are reminded of the profound impact these spacecraft have had on our collective understanding of the universe. They have revealed new mysteries and expanded the horizons of what we thought possible in space exploration. The wealth of data returned by the Voyagers continues to inform and inspire scientific research, pushing the boundaries of planetary science and astrophysics. Moreover, the legacy of the Voyager missions serves as a powerful testament to what humanity can accomplish when united by a shared vision to explore the unknown. Their epic journey into the far reaches of our solar system and now beyond into interstellar space symbolizes the enduring spirit of exploration that has driven humankind throughout history. It is a story of courage, determination, and the unquenchable thirst for discovery. The Voyager's Odyssey reminds us that space exploration is not merely about machines traveling through the cosmos, but about the collective dreams, hopes, and aspirations of all people who dare to look up at the stars and wonder. It inspires us to continue reaching higher, pushing further, and dreaming bigger. Ultimately, the story of Voyager 1 and Voyager 2 is a testament to the limitless curiosity that defines us as a species, an unending quest to understand the universe and our place within it. Their ongoing mission stands as a beacon of human achievement, encouraging future generations to carry forward this spirit of discovery, ensuring that our journey to the stars is far from over. In the vast, ever-expanding frontier of human exploration, there exists a journey so awe-inspiring and monumental that it transcends the very boundaries of time and space. This epic voyage is none other than the extraordinary odyssey of Voyager 1, a pioneering spacecraft launched by NASA that has traveled farther than any other human-made object, carrying the hopes and dreams of humanity into the deepest reaches of the cosmos. Recently, Voyager 1 sent back a historic transmission to Earth that has ignited waves of excitement and curiosity throughout the global scientific community and beyond. At the heart of this remarkable message lies a discovery of unparalleled significance, an enigmatic object detected in the profound, uncharted depths of interstellar space. This mysterious revelation has reignited one of the most timeless and compelling questions that has captivated humanity for generations. Could this signal represent the long-awaited moment when we finally establish contact with advanced extraterrestrial life? For centuries, humankind has gazed up at the night sky with wonder, imagining the possibility of other civilizations thriving among the stars. Now, this revelation has brought those age-old dreams tantalizingly close to reality. Voyager 1's journey began decades ago when it was launched on September 5, 1977, as part of NASA's ambitious Voyager program. Its mission was bold and profound: to act as Earth's emissary, venturing beyond the familiar realms of our solar system into the vast unknown, while meticulously studying the outer planets and their moons. Voyager 1's remarkable voyage was marked by a serendipitous cosmic alignment. It set off just 16 days before its twin, Voyager 2, beginning a cosmic ballet that has unfolded for more than 40 years. What truly sets Voyager 1 apart from countless other space missions is its extraordinary spirit of communication. Despite its unfathomable distance from Earth, Voyager 1 maintains a steadfast dialogue with our home planet through NASA's venerable deep space network. This complex and powerful communication system allows Voyager 1 not only to receive commands, but also to transmit back invaluable streams of scientific data, bringing us ever closer to understanding the cosmos. As of the latest measurements, Voyager 1 is an astonishing 159.32 astronomical units AU away from Earth, equivalent to nearly 23.8 billion kilometers, or approximately 14.8 billion miles. This staggering distance makes it the most distant human-made object ever to voyage into space. Yet, despite this incredible remoteness, Voyager 1's instruments continue to operate, tirelessly collecting and sending back information that deepens our understanding of the universe around us. Voyager 1's primary mission was to explore the outer boundaries of the Heliosphere, the vast bubble of charged particles and magnetic fields generated by the Sun. This outer boundary, called the heliopause, marks the frontier where the influence of our star gives way to the cosmic environment of interstellar space. Crossing this threshold in 2012, Voyager 1 became the first human-made object to enter the space between stars, beginning a new chapter in space exploration. What makes Voyager 1's mission truly remarkable is not only its groundbreaking discoveries, but also its extraordinary endurance. Originally designed to last only a few years, Voyager 1 has surpassed all expectations, continuing its interstellar journey for over 4 decades. Each day, it cruises through the void at an incredible speed of approximately 38,000 miles per hour, sending precious data back to Earth across billions of miles. Scientists anticipate that Voyager 1 will continue this historic mission at least until 2025, when its power sources are expected to diminish. Equipped with a sophisticated suite of 10 scientific instruments, including cameras, infrared and ultraviolet sensors, magnetometers, plasma detectors, cosmic ray sensors, and radio science equipment, Voyager 1 was built to be humanity's eyes and ears in the cosmos. These instruments have enabled the spacecraft to withstand the harsh and unforgiving conditions of deep space, while delivering an unprecedented wealth of knowledge about the outer solar system and beyond. Among Voyager 1's most celebrated achievements are its close flybys of two colossal gas giants, Jupiter and Saturn. In 1979, Voyager 1 made its first close approach to Jupiter, revealing breathtaking details about the planet's turbulent atmosphere, intricate ring system, and diverse moons. The spacecraft's instruments confirmed the existence of faint rings around Jupiter, previously only theorized, and uncovered previously unknown moons that added to our understanding of the planet's complex environment. A year later, in 1980, Voyager 1's encounter with Saturn provided equally stunning insights. It unveiled the intricate structure of Saturn's iconic rings, captured detailed images of its moons, and deepened our knowledge of the planet's magnetic field and atmosphere. These flybys not only revolutionized planetary science, but also inspired a new generation of explorers, scientists, and dreamers around the world. One of the most iconic moments in Voyager 1's journey came in 1990, when the spacecraft, prompted by the visionary astronomer Carl Sagan, turned its cameras back toward Earth and captured the now famous image known as the pale blue dot. In this extraordinary photograph, Earth appears as a tiny speck suspended in a vast cosmic ocean, a fragile and precious home floating in the immense void of space. This image remains a powerful symbol of humanity's shared vulnerability and interconnectedness, reminding us of the urgent need to cherish and protect our only home. As Voyager 1 continues its silent journey through the darkness beyond our solar system, it carries with it the legacy of human curiosity, ingenuity, and the unquenchable desire to explore. Its latest discovery in the depths of interstellar space hints at new cosmic mysteries waiting to be unveiled, perhaps even the momentous encounter with other life forms that so many have dreamed about. This odyssey, which began over 4 decades ago, continues to inspire and challenge us, inviting us all to look up, wonder, and reach ever further into the vast expanse of the universe. Voyager 1 was designed to push the boundaries of human knowledge, traversing vast distances where no spacecraft had dared to go before. Equipped with a suite of sophisticated scientific instruments, it was tasked with studying the giant planets and their moons, capturing unprecedented data that would forever change our understanding of the solar system. What makes Voyager 1 truly extraordinary is not just its groundbreaking discoveries, but its resilience and longevity. Despite being launched over 4 decades ago, it continues to send invaluable information back to Earth, maintaining a lifeline of communication through NASA's Deep Space Network. This unwavering connection allows scientists to receive data from more than 14 billion miles away, a testament to human ingenuity and determination. As Voyager 1 journeys beyond the heliosphere, the protective bubble created by the sun's solar wind, it enters interstellar space, a vast expanse filled with cosmic mysteries. Recently, a signal from Voyager 1 revealed the detection of an enigmatic object lurking in this farthest frontier. This revelation has sent shockwaves through the scientific community and reignited a question that has fascinated humanity for generations. Are we alone in the universe? The possibility that this mysterious detection could be evidence of advanced extraterrestrial life has captivated imaginations worldwide, inspiring scientists, philosophers, and dreamers alike to ponder the cosmic significance of this discovery. As we delve deeper into Voyager 1's findings, we are reminded of the boundless curiosity that drives human exploration, our relentless quest to understand not only the universe, but our place within it. In this unfolding cosmic saga, Voyager 1 stands as a symbol of hope, perseverance, and the unquenchable thirst for knowledge. Its voyage is not merely a scientific endeavor, but a profound journey that connects us all, uniting humanity in awe of the infinite cosmos that stretches beyond our wildest dreams. An intriguing aspect of the Voyager mission narrative lies in the remarkable timing. Voyager 1 began its epic journey just 16 days ahead of its cosmic twin, Voyager 2. This serendipitous alignment lends a sense of cosmic symmetry to an unparalleled saga. Two intrepid emissaries of humanity launched in close succession, each destined to explore the uncharted realms of our solar system and beyond. What truly distinguishes Voyager 1 from countless other space missions is its indomitable spirit of communication, a lifeline that it maintains steadfastly with Earth across unimaginable distances. This extraordinary feat is made possible by NASA's venerable Deep Space Network, a robust and sophisticated communication infrastructure designed to ensure a constant dialogue between the spacecraft and its home planet. This unyielding link serves a dual purpose. It allows Voyager 1 to receive precise commands from mission control and, in return, to transmit a treasure trove of invaluable scientific data back to its terrestrial origins. According to the most recent data, Voyager 1 currently finds itself at an astonishing distance of approximately 159.32 astronomical units, AU, from Earth. To put this monumental achievement into perspective, this distance translates to an awe-inspiring 23.834 billion kilometers, or roughly 14.8 billion miles, away from the cradle of humanity. In other words, Voyager 1 is now the most distant human-made object in existence, a lone traveler venturing farther into the cosmic ocean than any other craft before it. This staggering remoteness not only speaks to the spacecraft's incredible durability and the brilliance of human engineering, but also marks a milestone in our quest to understand the universe around us. It is this incomprehensible remoteness that firmly establishes Voyager 1 as the most distant human-made object ever to embark on an odyssey into the vast cosmos. From the moment of its launch, Voyager 1's primary mission objective was clear and profoundly ambitious: to explore and meticulously scrutinize the boundaries of the outer Heliosphere, a mysterious and barely understood region known as the heliopause. This invisible boundary marks the outermost layer of the Sun's influence, the final frontier where the solar wind meets the vast interstellar medium, enveloping our entire solar system in a protective bubble. Through its relentless investigations, Voyager 1 has bestowed humanity with invaluable insights into the cosmos, especially within the confines of our immediate solar neighborhood. Propelled forward at an astonishing velocity of approximately 38,000 miles per hour, an incredible speed that allows it to traverse vast cosmic expanses day by day, the spacecraft continues to push the boundaries of exploration and knowledge. Yet, what truly sets Voyager 1 apart is not just its distance or speed, but its remarkable endurance. The spacecraft has not merely met expectations, it has far exceeded its originally projected lifespan. More than 4 decades after its historic launch, Voyager 1 remains operational, tirelessly sending back vital data from the farthest reaches of space. Its ongoing mission serves as a testament to human ingenuity, perseverance, and an insatiable desire to understand the universe around us. Voyager 1 has embarked on extraordinary decades of exploration, defying the limits of time and technology. Each passing day, this remarkable spacecraft dutifully records and transmits vital information about its celestial journey, offering humanity a continuous stream of priceless data from the edge of our solar system and beyond. Remarkably, Voyager 1 is expected to continue this awe-inspiring interstellar sojourn until at least the year 2025, a testament to its resilient propulsion systems and enduring power supply that have kept it operational far beyond initial expectations. By that time, it is estimated that Voyager 1 will have achieved an almost inconceivable distance of approximately 13.8 billion miles from the nurturing embrace of the Sun, a staggering measure of its pioneering voyage into the cosmic unknown. Accompanying Voyager 1 on this grand adventure is its celestial sibling, Voyager 2, both launched as part of NASA's legendary Voyager program. Together, they were equipped with a formidable array of 10 unique scientific instruments, each serving as sensory extensions of the spacecraft into the vast cosmos. This sophisticated ensemble of tools included television cameras, infrared and ultraviolet sensors, magnetometers, plasma detectors, cosmic ray and charged particle sensors, as well as state-of-the-art radio equipment, all meticulously designed to conduct groundbreaking experiments. These ingenious instruments have endowed Voyager 1 with the resilience and capability to withstand the harsh and unforgiving environs of deep space, allowing it to probe the unfathomable reaches of the unknown. One of the most indelible milestones in Voyager 1's storied journey was its close encounters with two of the most majestic and enigmatic bodies in our solar system, Jupiter and Saturn. These historic flybys provided humanity with an unprecedented window into the complexities and wonders of these gas giants, forever reshaping our understanding of the planetary giants and their moons. Voyager 1's encounters with the solar system's colossal planets, Jupiter and Saturn, were nothing short of historic. These celestial rendezvous, which occurred in 1979 and 1980, respectively, marked a watershed moment in the annals of scientific discovery. Through these close flybys, Voyager 1 gifted humanity with an unprecedented glimpse into the intricate complexities of these gas giants and their enigmatic retinues of moons. The spacecraft etched its name indelibly into history by uncovering previously unknown moons orbiting these planets, and by revealing the intricate and delicate ring structures that encircled both Jupiter and Saturn. Prior to Voyager 1's mission, much of this was speculation or incomplete knowledge. Its groundbreaking revelations not only captivated the scientific community, but also ignited the imaginations of people across the globe, heralding a new era of planetary exploration. One of Voyager 1's most iconic and enduring contributions to our cosmic understanding came in 1990 when the celebrated astronomer Carl Sagan championed a visionary concept. He urged the spacecraft to pivot its cameras and direct its lens back towards Earth. This simple yet profound act resulted in the creation of the now famous image known as the pale blue dot. The resulting image, now deeply etched into the collective consciousness of humanity, depicts Earth as a minuscule pale blue dot suspended in the vast cosmic ocean. This poignant image serves as a humbling reminder of the fragility and interconnectedness of our planet, underscoring the imperative to cherish and protect our world. A message that continues to resonate powerfully with people around the globe. Voyager 1's epic journey through the cosmos led it to encounter two of the most enigmatic and majestic celestial bodies in our solar system, Jupiter and Saturn. These monumental encounters provided a treasure trove of scientific data and imagery, fundamentally reshaping our understanding of these gas giants. Jupiter, the largest planet in our solar system, beckoned Voyager 1 with its beguiling mysteries. In March 1979, the spacecraft conducted a close flyby of this colossal giant, granting humanity its first intimate glimpse of the planet's immense scale and complexity. As Voyager 1 ventured closer, it unveiled a tapestry of astounding discoveries, one of the most captivating being the confirmation of Jupiter's intricate ring system. Before Voyager 1's arrival, these faint rings were only a hypothesis, but the spacecraft's keen instruments provided definitive evidence of their existence. Composed of fine, dark particles, these delicate rings encircle Jupiter in an ethereal fashion. The images captured by Voyager 1 offered an entrancing perspective on this subtle feature, captivating the world with their delicate beauty and adding a new dimension to our cosmic knowledge. Another remarkable revelation from Voyager 1's encounter with Jupiter was the unveiling of intricate weather patterns and tempestuous storms on the gas giant's surface. Among these tempests, the most iconic was the Great Red Spot, a colossal storm that has raged for centuries. Voyager 1's imagery of this mammoth tempest not only illuminated the storm's complex structure and dynamic behavior, but also ignited the public's fascination with Jupiter's tumultuous atmosphere. Furthermore, Voyager 1's instruments detected Jupiter's powerful magnetosphere, a colossal magnetic field that dwarfs Earth's own magnetic envelope. This groundbreaking discovery provided crucial insights into the planet's magnetic dynamo and shed light on how this immense magnetic field interacts with its retinue of moons, influencing their environments and contributing to the complex space weather around Jupiter. Following its momentous encounter with Jupiter, Voyager 1 continued its epic odyssey toward Saturn, the majestic ringed planet. In November 1980, the spacecraft made its closest approach to this cosmic wonder, offering humanity an intimate view of Saturn's stunning rings and captivating moons. The detailed images and data collected unveiled previously unseen features of the ring's delicate structure and composition, as well as the diverse geology and atmospheres of Saturn's many moons. One of Voyager 1's most iconic contributions to human perspective came in 1990 with the celebrated pale blue dot image. The esteemed astronomer Carl Sagan championed a visionary idea. He implored the spacecraft to pivot its cameras and turn its lens back toward Earth. This image immortalized our planet as a tiny, fragile speck suspended in the vastness of space, inspiring reflection on our place in the cosmos and a renewed commitment to safeguarding our shared home. The resulting image, now etched deeply into the collective consciousness of humanity, depicts Earth as a minuscule pale blue dot suspended in the vast cosmic ocean. This poignant and humbling image serves as a powerful reminder of the fragility, vulnerability, and profound interconnectedness of our planet within the boundless expanse of the universe. It underscores the urgent imperative to cherish, protect, and preserve our delicate home, a message that continues to resonate with people from all corners of the globe, inspiring reflection on our shared responsibility to safeguard life on Earth. While Voyager 1's extraordinary odyssey primarily focused on the majestic gas giants Jupiter and Saturn, its twin spacecraft, Voyager 2, embarked on a distinct and equally remarkable trajectory. Voyager 2 was destined to explore the enigmatic ice giants of our solar system, Uranus and Neptune, planets shrouded in mystery and complexity, presenting a fresh array of cosmic enigmas for scientists and humanity to unravel. Uranus, the seventh planet from the Sun, is a celestial enigma for many reasons, not least of which is its extraordinary rotation. Unlike any other planet in our solar system, Uranus rotates on its side, with an axial tilt of approximately 98 degrees. This unusual orientation is believed to be the aftermath of a colossal and cataclysmic collision with a massive celestial object in the distant past, which drastically altered the planet's spin. This tilt results in extreme seasonal variations lasting over decades, offering a unique glimpse into planetary dynamics that differ greatly from those of Earth and its planetary neighbors. Despite its unusual tilt and mysterious origins, Uranus remains a captivating and fascinating world. It is approximately 4 times the diameter of Earth and boasts a cold, icy atmosphere composed mainly of hydrogen, helium, and methane, giving it a characteristic blue-green hue. Voyager 2's historic flyby of Uranus in January 1986 marked a momentous milestone in space exploration. For the first time, humanity received detailed images and comprehensive scientific data of this distant ice giant, expanding our knowledge far beyond previous telescopic observations. Among the many groundbreaking discoveries during Voyager 2's encounter was the revelation that Uranus possesses a complex system of rings, a surprising finding since rings were once thought to be unique to Saturn. Voyager 2 revealed that these rings consist of dark, narrow bands composed of tiny particles and debris orbiting the planet, hinting at dynamic processes within Uranus's gravitational influence. In addition to its rings, Voyager 2 discovered 10 new moons orbiting Uranus, each with its own unique characteristics and geological histories. The spacecraft's instruments also provided valuable insights into the planet's atmosphere, uncovering high-speed winds and unexpected temperature variations that challenged existing models of planetary atmospheres. These findings offered a new window into the workings of ice giants, enriching our understanding of planetary formation and behavior in the outer solar system. Voyager 2's journey did not end with Uranus. It continued onward to Neptune, the outermost planet in our solar system, arriving in August 1989. Neptune, with its striking deep blue color and fierce weather systems, presented yet another frontier of exploration and discovery. The data and images sent back by Voyager 2 from Neptune's vicinity revealed powerful storms, supersonic winds, and a moon with active geysers. An astounding discovery that further deepened our appreciation for the dynamic complexity of these distant worlds. Together, the twin Voyager spacecraft have revolutionized our understanding of the solar system's outer realms. Their pioneering missions, spanning more than 4 decades, have transformed once faint and distant dots in the night sky into vividly detailed worlds, full of mystery and wonder. These missions continue to inspire generations of scientists, dreamers, and explorers, reminding us that even at the very edges of human reach, the universe holds countless secrets waiting to be discovered. Voyager 2 revealed a diverse and captivating retinue of moons orbiting Uranus, each possessing unique geological and atmospheric features. Among these, moons like Miranda, Ariel, and Titania stood out, showcasing dramatic landscapes marked by massive canyons, unusual fault lines, and evidence of past geologic activity. These discoveries significantly enriched humanity's understanding of Uranus, shedding light on the complex interactions between the planet and its satellites, and deepening the intrigue surrounding this enigmatic, sideways rotating giant. Voyager 2's interstellar voyage did not end at Uranus. It pressed onward, journeying even farther to reach Neptune, the eighth and most distant known planet from the Sun. Neptune, with its frigid temperatures and vibrant azure hue, remains a haunting symbol of the solar system's outer frontier. This distinct blue coloration is due to the high concentration of methane in its atmosphere, which absorbs red light and reflects the blue. In August 1989, Voyager 2 conducted a historic flyby of Neptune, marking the first, and so far only, close encounter with this distant world. The images and data transmitted back to Earth during this flyby were nothing short of revolutionary. Voyager 2 unveiled a planet with a surprisingly dynamic atmosphere, teeming with violent storms and fierce winds, the fastest sustained winds recorded in the solar system, reaching speeds of over 2,000 kilometers per hour, about 1,200 miles per hour. Among Neptune's most notable atmospheric features was the discovery of the Great Dark Spot, a colossal storm system reminiscent of Jupiter's famous Great Red Spot. However, unlike its Jovian counterpart, the Great Dark Spot proved to be ephemeral. It mysteriously vanished in later observations, raising questions about the atmospheric dynamics of Neptune and the transient nature of its weather system. Perhaps one of the most astonishing revelations from Voyager 2's Neptune encounter was the discovery of the planet's largest moon, Triton, to be an exceptional celestial body that defied expectations. Triton orbits Neptune in a retrograde direction, meaning it moves in the opposite direction of Neptune's rotation, a rare trait that strongly suggests Triton is a captured object, possibly a former Kuiper Belt object that was gravitationally ensnared by Neptune in the distant past. Triton's surface was revealed to be a frozen yet geologically active world, exhibiting nitrogen geysers erupting from beneath its icy crust, a phenomenon never before observed on a celestial body so distant from the Sun. This cryovolcanic activity indicated that Triton, despite its remoteness and frigid temperatures, harbors internal heat and dynamic processes beneath its surface. Voyager 2's images showed a landscape marked by frozen plains, ridges, and sparsely cratered terrain, suggesting a young and possibly evolving surface. These groundbreaking discoveries at Neptune and Triton not only captivated the global scientific community, but also sparked the imaginations of people around the world. The Voyager 2 mission demonstrated the boundless potential of human curiosity and ingenuity, reminding us that even the most remote and mysterious corners of our solar system can be brought into the realm of human understanding. Voyager 2's historic flybys of Uranus and Neptune marked the end of humanity's first grand tour of the outer planets, a monumental chapter in the annals of space exploration. Yet, like its twin Voyager 1, Voyager 2 continues to voyage beyond the known, transmitting faint whispers of data from the edge of interstellar space, ensuring that its legacy endures not just in scientific discovery, but in the shared human spirit of exploration. Triton, the largest moon of Neptune, emerged as one of the most fascinating and enigmatic celestial bodies encountered during Voyager 2's interplanetary odyssey. The spacecraft's imagery revealed a world brimming with activity, despite its remote location and frigid climate. Among Triton's most extraordinary features were geysers that erupted from beneath its icy surface, spewing nitrogen gas high into the Moon's thin atmosphere. These geysers created vast plumes that extended kilometers above the surface, where the nitrogen would condense into snow-like particles and gently settle back to the ground, sculpting a surreal and alien landscape of frost and ice. This striking phenomenon was unlike anything previously observed in the solar system, offering profound insights into cryovolcanism, the eruption of volatile substances like water, ammonia, or methane, rather than molten rock. Triton's surface, relatively young and sparsely cratered, hinted at a geologically active history, defying expectations for a moon so far from the Sun. Perhaps even more puzzling was Triton's retrograde orbit. It revolves around Neptune in the direction opposite to the planet's rotation. This uncommon trait strongly suggests that Triton did not form alongside Neptune, but was instead a captured object, likely originating from the Kuiper Belt. Its gravitational capture would have disrupted Neptune's original satellite system and left Triton locked in a stable but unusual orbital dance, one that continues to intrigue astronomers to this day. Voyager 2's encounters with Uranus and Neptune remain unparalleled achievements in the history of space exploration. To this day, no other spacecraft has visited these distant ice giants, making Voyager 2's observations and data collection an irreplaceable scientific treasure. The trove of information gathered during these historic flybys continues to fuel research and hypotheses, offering glimpses into the atmospheric dynamics, magnetic fields, ring systems, and unique satellite compositions of these mysterious worlds. While Voyager 2 was delving into the secrets of the outer planets, its twin, Voyager 1, was forging an even more audacious path, a journey that would take it beyond the boundaries of the solar system and into interstellar space. This transition, which occurred in August 2012, marked a profound and historic milestone for humanity. For the first time, a human-made object had crossed the heliopause, the boundary where the solar wind yields to the interstellar medium. Voyager 1's entry into interstellar space did not signify the end of its mission, but rather the beginning of a new chapter. As it continues its voyage through the vast and silent reaches of the cosmos, it carries with it not only scientific instruments, but also a symbolic message from Earth, etched in the form of the Golden Record, a phonograph disc containing sounds, music, and greetings from our planet. Now billions of miles from Earth, Voyager 1 operates in a realm beyond the Sun's influence, where the environment is dominated by particles, fields, and forces that originate from other stars. Its instruments, though fewer in number now, continue to return invaluable data about the nature of interstellar space, helping scientists to understand the shape and boundary of the heliosphere and the conditions in the space between the stars. The enduring journey of the Voyager spacecraft, Voyager 1, venturing outward into the galaxy, and Voyager 2, providing the only close-up views of Uranus and Neptune, remains one of the most ambitious and successful missions in the history of space science. They have not only expanded the boundaries of human knowledge, but have also inspired generations to look upward and dream of what lies beyond, gathered groundbreaking data that challenged earlier assumptions and reshaped our understanding of this mysterious frontier. Rather than a simple comet-like structure with a long tail trailing away from the Sun, Voyager 1's measurements suggested that the heliopause is more complex, possibly a distorted bubble-like shape influenced by both the solar wind from within and interstellar forces from beyond. As Voyager 1 crossed this boundary in 2012, it recorded a sudden and lasting drop in solar particles, while simultaneously detecting a surge in galactic cosmic rays, energetic particles that originate from supernovae and other powerful cosmic phenomena far outside our solar system. This was the smoking gun, clear empirical evidence that the spacecraft had exited the heliosphere and entered the vast ocean of interstellar space. Within this realm, Voyager 1's instruments continued to function, albeit in a limited capacity due to the fading power supply and increasing distance. Even so, its plasma wave subsystem detected a persistent background hum, long, low-frequency vibrations in the plasma of interstellar space. This discovery provided an unprecedented glimpse into the density and behavior of particles between the stars, and demonstrated that the void of space is, in fact, filled with subtle and dynamic forces. Voyager 1's ongoing mission in interstellar space is a testament to both technological resilience and scientific ambition. It represents the first time humans have been able to directly measure the environment of interstellar space, rather than relying solely on telescopes or theoretical models. The data sent back by Voyager 1 continues to challenge assumptions and refine our models of how the Sun interacts with the galaxy around it. As it sails farther into the unknown, Voyager 1 is also pushing the limits of communication, its faint signals traveling at the speed of light now take over 22 hours to reach Earth. Each byte of data is a time capsule, whispering stories from the edge of the solar system to a waiting world. Despite being over 46 years old, the spacecraft continues to surprise. In recent years, engineers have performed innovative workarounds to keep it operational, including rerouting functions through backup systems. These efforts ensure that even in its twilight years, Voyager 1 remains a pioneer, a silent emissary of Earth, drifting among the stars. Its journey into interstellar space is not just a scientific achievement, but a symbolic one. Voyager 1 carries the golden record, a carefully curated message intended for any intelligent life that might one day encounter it. Engraved with greetings in 55 languages, music from cultures across the Earth, and images depicting life on our planet, the golden record serves as humanity's cosmic calling card, a whisper to the universe saying, "We were here, we reached this far, and we are curious." Voyager 1 is now far beyond the planets, beyond the influence of our star, continuing its voyage in the silence of deep space. It is alone, yet never forgotten. His legacy etched into history, its mission ongoing, and its story inspiring countless new explorers to reach for the stars. These observations from Voyager 1 provided a transformative understanding of the heliopause and its complex relationship with the galactic environment. Prior to Voyager's journey, much of what scientists knew about the heliosphere was theoretical, based on models, simulations, and indirect evidence. But as Voyager 1 approached and eventually crossed the heliopause, it delivered empirical measurements that revolutionized the field. One of the most unexpected discoveries was the behavior of the magnetic field at the boundary. Scientists had expected a sharp shift in the direction of the magnetic field lines as Voyager 1 transitioned from the Sun's influence to the interstellar medium. However, what they observed was a subtle and unexpected continuity. The magnetic field beyond the heliopods remained aligned in a way that puzzled researchers. This anomaly suggested that the heliosphere might not be as sharply defined or as neatly contained as once imagined. Instead, it could be intertwined or blended with interstellar forces in ways that challenge our understanding of the boundary between solar and galactic domains. These deviations hinted at previously unknown interactions between the solar wind and the interstellar magnetic field, painting a far more dynamic and fluid picture of the Sun's outermost frontier. In addition to its findings on magnetic fields, Voyager 1 also measured plasma density in interstellar space. Unlike within the solar system, where plasma is sparse and influenced by solar activity, the interstellar medium was found to be denser, yet cooler and more stable. This provided critical data that helped astronomers refine their understanding of the material that fills the vast regions between star systems. Voyager 1's traversal into and beyond the heliopause did more than just expand the scientific boundaries of astrophysics. It redefined the scale of our solar system. What was once thought to end at the orbit of Pluto, or perhaps Neptune, was now clearly shown to extend tens of billions of kilometers farther. Enveloped in a vast and shifting magnetic bubble, these findings are not merely academic. They have profound implications for future missions and our long-term aspirations for space travel. Understanding the heliosphere structure is essential for developing technologies that could one day protect human explorers from cosmic radiation as we venture further from Earth. It also helps in mapping the interstellar environment that any spacecraft, robotic or crewed, would encounter as it journeys to the stars. In essence, Voyager 1's study of the heliosphere turned a once theoretical concept into a tangible and measurable structure, revealing it as a living, breathing force field that protects and defines the domain of our Sun. And while many questions remain about its shape, its interaction with the galaxy, and how it evolves over time, Voyager 1 laid the first real footprints on this invisible frontier. It's a testament to human curiosity and engineering that a spacecraft launched in 1977 continues to inform us decades later about regions of space we had never directly touched before. The mission of Voyager 1 not only broadened our understanding of the heliosphere, but also reminded us that exploration, no matter how distant or difficult, brings us closer to the truth of our place in the cosmos. These contrasting environments encountered by Voyager 1 and Voyager 2 as they crossed the heliopause added profound depth to our understanding of interstellar space. Although both spacecraft pierced the boundary that separates the Sun's protective bubble from the galaxy beyond, the variations in local space weather, magnetic field intensity, and particle density between their paths suggested that interstellar space is not uniform. It is a complex and evolving landscape, shaped by both local and galactic forces. Voyager 2's instruments, still fully operational at the time of its heliopause crossing, recorded direct plasma measurements, something Voyager 1 could not do initially due to a malfunction in its plasma instrument. This allowed Voyager 2 to directly confirm the dramatic rise in plasma density beyond the heliopause, complementing the data Voyager 1 had previously inferred using its cosmic ray and magnetic sensors. This corroboration between two different observational methods provided compelling evidence for a denser interstellar medium just outside our solar system. Moreover, the turbulence Voyager 2 encountered, manifested as fluctuating magnetic fields and wave-like plasma interactions, indicated a more chaotic boundary layer. Scientists hypothesize that this may be due to differences in solar wind pressure or local interstellar cloud structures that distort the heliosphere's edge. In contrast, Voyager 1's path appeared to be through a calmer, more sensitive this frontier is to cosmic condition. Together, these findings from both spacecraft are enabling scientists to create the first three-dimensional models of the heliosphere's outer boundary, which help illustrate its shape, behavior, and interaction with the galaxy. These models are crucial not only for understanding our own solar environment, but also for contextualizing the protective magnetic bubbles that might surround other stars, possibly shielding exoplanets from harmful radiation and influencing their potential to host life. In essence, Voyager 1 and Voyager 2, though launched within weeks of each other, have become dual ambassadors to the galaxy, each offering a distinctive lens on the final frontier of our solar system. Their separate experiences highlight that the edge of our solar system is not a fixed wall, but a living, breathing boundary, shaped by the solar wind's strength, the interstellar medium's density, and galactic magnetic fields that we are only beginning to understand. As Voyager 2 continues its journey through this turbulent interstellar zone, it adds more layers to the grand narrative begun by its twin. Together, they are charting a realm never before visited by humankind. And in doing so, they remind us that even at the edges of our influence, human curiosity and ingenuity still thrive. Reaching out into the unknown, guided by the faint whispers of data traveling billions of kilometers back to Earth, journey marks both a triumph of engineering and a poignant reminder of the finite nature of even our most enduring creations. Now well over 46 years since its launch, Voyager 1 continues to drift deeper into the uncharted sea of interstellar space, carrying with it the legacy of Earth's first true attempt to reach beyond the confines of the Sun's domain. Yet, as the spacecraft travels ever farther, it faces increasing challenges. Its power supply, generated by radioisotope thermoelectric generators, RTGs, is gradually weakening. As of now, NASA engineers have been shutting down non-essential systems to conserve energy and extend the mission's lifespan. Sometime in the late 2020s or early 2030s, Voyager 1 will likely go silent, as its power becomes insufficient to sustain even the low-energy communications that still reach Earth today. Despite this inevitable silence, the spacecraft will not stop traveling. Long after it can no longer send signals or power its instruments, Voyager 1 will continue coasting through the Milky Way galaxy, a silent sentinel bearing the golden record, waiting for a distant intelligence, if such an intelligence exists, to encounter it. This golden record, painstakingly curated by a team led by Carl Sagan, includes greetings in 55 languages, music from a wide range of cultures and eras, from Bach and Beethoven to traditional songs from Japan, Senegal, and Peru. Images depicting life on Earth, human anatomy, architecture, DNA structures, and the planet's ecosystems. Sounds of Earth, including the laughter of a child, the roar of the ocean, thunder, and the chirping of birds. These records serve as a kind of cosmic message in a bottle, not with the hope of rescue, but as a declaration: we were here. We reached for the stars. We tried to understand the universe and ourselves. In this way, Voyager 1 and Voyager 2 have transcended their original scientific missions. They have become monuments of human creativity and persistence, testaments to a civilization that dared to send its voice into the dark with no guarantee of reply. They represent an act of faith in the future, a belief that knowledge, wonder, and the desire to explore are enduring parts of what it means to be human. As we gaze toward the heavens, tracking the faint signals from these emissaries, we are reminded that our reach has already extended beyond the solar system, and that even in the cold emptiness of space, our story continues. The Voyager mission teaches us that the journey itself, filled with discovery, wonder, and enduring hope, is as important as the destination. Voyager 1's incredible journey has reignited the world's fascination with this fearless spacecraft after more than 4 decades of exploration. Voyager 1 has traveled far beyond our solar system, venturing deep into interstellar space. It has crossed the heliopause, the boundary where the sun's influence fades, and now drifts through a vast, uncharted region of the galaxy. In August 2022, Voyager 1 sent a mysterious message back to Earth, one that captured the imagination of scientists and space fans everywhere. Amid streams of data and telemetry, researchers detected a strange anomaly, an object of unknown origin and makeup. Tentatively named the Cosmic Enigma, this object is unlike anything ever encountered in the history of space exploration. What makes the Cosmic Enigma so puzzling? It emits faint, irregular signals that don't match any known natural celestial phenomena. Even more intriguing, its path through space seems deliberate, as if it's following a specific course through the cosmos. This discovery raises deep and fascinating questions. Where did this object come from? Who or what created it? And what might its intentions be? Scientists and astronomers around the world have been meticulously analyzing the data sent by Voyager 1, determined to unlock the secrets of the mysterious cosmic enigma. Could this baffling object be a remnant of an advanced extraterrestrial civilization, or perhaps a probe launched from a distant corner of the galaxy? Alternatively, might it be an entirely new and unknown cosmic phenomenon? The discovery has ignited a wave of speculation and debate, bringing together experts from diverse fields who are collaborating to unravel the enigma's true nature. One leading theory suggests that the cosmic enigma could be an ancient relic from a long-lost civilization, a probe dispatched eons ago, its original mission veiled in the mists of time. Whether its purpose was scientific, exploratory, or something beyond our imagination remains an intriguing mystery. On the other hand, some scientists propose that this object might be a natural celestial phenomenon, with properties that challenge our current understanding of astrophysics. This possibility reminds us of the universe's immense complexity and the vast diversity of cosmic phenomena still waiting to be discovered. It highlights how much we have yet to learn and how little of the universe's secrets we have uncovered. The detection of the cosmic enigma underscores the critical importance of continued space exploration. It calls for humanity to push further into the cosmos, to embrace the unknown, and to expand our cosmic reach. The universe is a vast, mysterious frontier, filled with wonders and enigmas that inspire awe and curiosity. As Voyager 1 continues its solitary voyage through interstellar space, carrying with it the mystery of the cosmic enigma, humanity stands on the brink of new discovery. This spacecraft has become Earth's ambassador to the stars, a shining symbol of our insatiable curiosity and unyielding desire to explore. Voyager 1's odyssey, spanning over 4 decades, has fundamentally reshaped our understanding of the universe. It continues to inspire generations of scientists, dreamers, and stargazers alike. As we ponder the mysteries of the cosmic enigma and the endless possibilities it represents, we are reminded that the cosmos is a vast, wondrous, and ever-evolving realm. Each new discovery brings us closer to answering one of humanity's most profound questions. Are we alone in the universe? With its indomitable spirit and enduring mission, Voyager 1 carries our hopes and dreams as it forges onward into the cosmic unknown. The story of Voyager 1 is a testament to the enduring human spirit of exploration, curiosity, and the relentless quest for knowledge. It transcends time and space, reminding us of our place in the universe and the boundless wonders awaiting us in the cosmic expanse. The enigma of the cosmic enigma serves as a poignant reminder that the universe is filled with mysteries yet to be unraveled. It invites us to continue our cosmic journey with wonder and humility, ever eager to explore the depths of the unknown. Voyager 1, humanity's cosmic emissary, continues to inspire us to reach for the stars and embrace the infinite possibilities that lie beyond.